Francis Collins is the former director of the National Institutes of Health and leader of the Human Genome Project. For GenomeWeb's 25th anniversary, managing editor Julia Caro spoke with him about the completion of the project, how it paved the road to precision medicine, and the future of the NIH.
A little more than 25 years ago, you stood in the East Room of the White House with President Clinton and with Craig Venter announcing the completion of the first map or the first draft of the human genome. President Clinton called this at the time the most important, most wondrous map ever produced by humankind. What were you thinking back then? What were your expectations?
Well, it was a memorable day, June 26th, the year 2000. And it had been quite a mad dash to get to that point. There had been, as you know, a competition between the private effort that Craig was leading at Celera and the public effort, the Human Genome Project. And things had gotten a little tense about that. And I personally had worked hard to try to come up with a better outcome where we could announce both projects at the same time and not have it be a race to the finish line. And ultimately, I think the Human Genome Project public effort was vindicated in its strategy to make all the data publicly accessible immediately, which was something we had been doing since 1996 by putting all the data up every 24 hours. Which made the commercial effort, which was going to require a subscription to see the human DNA sequence, no longer viable, and it kind of disappeared fairly soon after that. So I was thinking about on that day that it was great we had reached this point of being able to tell the public that we have seen the first glimpse of our own instruction book. It was a draft. It was about 90%, but there was a lot of things we could say. We had already learned about it. Personally, for me, it was also a poignant moment because I had just spoken at the funeral of my much too young sister-in-law the Saturday before that Monday, who died of breast cancer. And I had all these hopes that studying the genome was going to start to help that, but it was much too late for her.
The Human Genome Consortium then went on to publish the first draft in 2001, and then in 2003, you and the consortium declared the project completed. And actually, at that time, we had you at the cover, on the cover of our now discontinued magazine, Genome Technology, as our Person of the Year 2003. You said in that interview, when we get to the point where we can say we changed medicine, then I'll feel like we got somewhere. Yeah. So, have we gotten somewhere?
We have gotten somewhere, but we have much more yet to go. The ability to sequence genomes now at really low cost and high throughput and rapid turnaround has turned cancer management into a totally different scene than it used to be. That we really have arrived at the point of precision oncology, where anybody who develops cancer, and I'll speak about myself because I'm a prostate cancer survivor, you will want to know what are the mutations in your cancer that are driving those good cells to go bad, and how would that help you optimize the therapy. Other areas you can see, goodness, go to the newborn ICU and see the way in which genomics is transforming the ability to figure out what is happening with a very sick infant. And genome sequences now give answers, something like 40% of the time in those puzzling diagnostic dilemmas, and many of those are actionable, which gives you a better chance to help that infant survive. Look at infectious disease, the ability during COVID, for instance, to be able, like lightning speed, to find out, oh, here is a new variant of SARS-CoV-2 because we just sequenced it.
And these technologies are also transforming medicine now with the first CRISPR-based treatments. And along those lines, where do you see all this going in the next 25 years, also considering all these new capabilities we're getting from AI?
I'm very much somebody been devoted for my whole life as a researcher towards rare diseases. It thrills me no end to see sickle cell disease now being cured with a CRISPR-based approach. But it's still an approach that's rather challenging and expensive, requiring an ex vivo gene editing of hematopoietic stem cells. I'm excited to see progress being made on an in vivo approach for treating genetic diseases, including sickle cell. My own lab at NIH spent many years building towards the point, which is now within perhaps a year, of doing the first in vivo gene editing trial for progeria, the rarest form of premature aging. But I think of that not only as a particular disease that desperately needs a better answer, but also maybe the leading edge of what we could think about doing for those 7,000 rare genetic diseases where we know the DNA misspelling, but currently we don't have a treatment. And there's no reason those 7,000 diseases could not be approached at an affordable cost in the course of the next 15 or 20 years. And AI will help us there as well, because it helps you do a better and better job of designing your editors to be highly effective and to limit the amount of off-target problems that you might have to face.
Let's talk about the present for a few minutes. So the NIH and federal research funding in general have been, I want to call it a little bit in a period of turmoil recently. So what's your advice to both your former NIH colleagues and also to young scientists who have been affected by recent cuts and uncertainty of funding?
Well, it has been an extremely difficult year in 2025. I came to NIH in 1993. I went through a whole variety of administration changes, but there was nothing that came close to what has happened in the last 7 or 8 months in 2025 in terms of the dismantling of an incredibly successful enterprise. An engine for discovery has had all kinds of sand put into the gears, and much of it done in a heartless and careless way, so that it was not that we were trying to improve efficiency of a complicated organization, which is always something one should strive for. But this was not done that fashion. This was move fast and break things in a Silicon Valley approach without considering the consequences. It is heartbreaking to see some of the things that have happened as a result. Clinical trials that have been stopped in the middle and people waiting on results for such things. Certainly trainees who are looking towards the future that they want to be part of are deeply worried about whether the United States is going to be the place where they can live out those dreams or whether they have to go to another field or another country. And I'm currently engaged in an effort to try to get more patient stories in front of people across the country so that they understand that medical research breakthroughs don't just happen by good luck. They're based upon years, oftentimes, of investment, and investment that requires the federal government or it doesn't work. We should all be completely willing to talk about why this matters, to avoid turning that into a political mudslinging, because that doesn't help, but to try to convince the exhausted middle of America, which is about 2/3 of the country, some a little blue, some a little red, that this is one area that should never have been partisan, and we should all figure out how to get it back on track again.